Hi, Nate.
Howdy, howdy.
Are you in class or are you in a break still?
I'm still on break. I don't go back to class until like the 29th.
Cool. Cool.
So
All right. So then you have no excuse for not writing a paper. uh, can't help but bug you about that.
yeah, no, I've mainly been just waiting on getting these classes so that I can actually sit down and work. But
Okay. Looks like we've got a good start here. Yeah.
Hello.
Hello,
howdy,
everybody.
howdy.
We even have
Hello.
Leon. By golly.
Hello,
How
Leon.
about that? Yeah.
Hello.
Great picture. So, I don't know who else. Oh, we got Rick coming too. Good. Okay. Good. Dave, are you packed up to go on your trip? Not yet, I guess.
In a week, I'll start
Yeah.
worrying about that. Hello. Hello, everybody.
Hi. Good. Good. Great. I think we've got quorum. Yeah.
Okay.
Yeah. I'll let if Russ is still there, let Russ has sort of got the primary agenda here. So Russ, you want to go ahead and get us started?
Well, I don't have anything real special. Sophie could tell us how the astronomy research experience is coming along, and Scott might comment on how we're doing on speckle automation. Sophie?
Yeah, I guess I could get started. Research experience is going pretty well so far. Also, sorry about if you can hear a bunch of background noise. We didn't have Wi-Fi this morning, so I am outside. So hopefully it's okay. But basically, the experience is going well so far. We're trekking along, finally trying to get some observations done. We're working on a bunch of different observation projects right now. One of them is the Scott target list, which we're trying to observe things on the Barrow system and on Scott system. But we finally were able to get some observations, which is good, and we'll be observing more tonight, which should be exciting. Crossing our fingers that it works. Last time we had to end a little early because of some high winds, which caused the star to go all over the place when we were trying to take some images. But hopefully the ones that we did manage to get ended up being okay, and the goal is to get the entire list done tonight, which maybe we'll do, maybe not, hopefully. But yeah, otherwise things are going well.
What time, Sophia?
6 p.m.
Yeah, I'll open up the observatory early. I still having problems with the SciTech, and but I've gotten so that I've gotten to several different routines down now so that I can debug it and get it operating again in most cases. So had to do it again last night a couple times. So I'll sit in at the beginning if I can to be sure you get off to a good start. Okay.
Sounds good to me.
Yes, Scott, could you talk a little bit about the automation?
Sure. Well, let's see. First of all, I missed Sophia's session last night because I was playing around in my backyard, see what I could do. And I got kind of some good news and bad news. The good news is that in Nina, we've talked about it being able to do subframes. And it's been kind of, the conclusion has been ambiguous. I didn't believe at first that you could do it. And then the last session we had with Nick, something he did just turned on a light or two on with me, and I was able to figure out how to do subframes in Nina without some other code. And so last night I tried that and was successful on the first target in the list that Russ provided. So I've got one collection on that particular target and a bunch more to go. And I don't know if we want to have students do that or have somebody look over my shoulder or how we want to handle it. But the bad news is that my pointing isn't real good. And so it's a non-trivial process to get the target star in the field of view. You have to do you have to be pretty careful how you do it. And that would be solved if I was able to do plate solving on my system with Nina. On a bunch of clusters, I tried ASTAP and was successful. So ASTAP works, but I haven't been able to work within the context of Nina with the configuration I have now. When I didn't have the Barlow in, ASTAP worked. But for some reason, I'm getting error messages out of Nina when I try to plate solve using ASTAP. So that's a little, my pointing is a little bit of a stumbling block right now. I think my polar alignment isn't real great. And so when I go, if I use a bright star and then slew to the target star, it isn't as accurate as it needs to be. And so I'm working on fixing that. And then we should be able to use this system one way or another. What else? I think that's most of what I've done.
A couple questions, Scott. One is, if it'd be all right with you, I'd love to just have students Zoom over your shoulder. I'd like to watch too. I think it's informative to watch things while they're being cleaned up and squared away, not after they're all actually working. So,
Yeah.
if that would work, just to let us know when you're doing something and just go about doing it like we weren't there and just turn on the Zoom.
Yeah, you want to see all the warts and everything. Yeah.
Exactly. I think that's really good education that they don't get in a normal labs and lecture course and so forth. Everything's been cleaned up. The labs are Clay said it once. You had a thing I would like to quote. Clay, how did you put, kind of doing it with the warts?
I was just quoting Dave in the chat saying that it's like the sausage making. That's how he puts it.
Yeah. Well, let's, I don't know, is the weather good tonight?
I think so, but I think Sophia schedules stuff on Barrow, is that right?
Oh, yeah, right.
Yeah, we have Barrow time tonight, but maybe tomorrow or Sunday night we could do something.
Yeah, let's keep our eye on the weather, and I'm not sure exactly what my schedule is, so I need to check with my management on that. And we'll pick a night and give it a try.
Yeah, the other thing, Scott, could you mention it? So it looked to me like, so in our meeting with Nick, that he's found a whole bunch of things already in Nina that he thinks he can, we can kind of put together a script that will.
Yeah. Oh, right.
Do
I
these
mean,
things.
the sequence function in Nina should allow us to do, the accounting on the different filters and the different exposure times and repeats and all that should be pretty well covered in the sequence function that's already built into Nina. And we just have to kind of make sure that we understand how to sequence images and how to save them where we want them. So it's there's an awful lot of functionality in Nina that does the sort of things that you were outlining in that write-up that you did, Russ. But there's some things that are driving me nuts in Nina. One is that you would like to be able to adjust the position of the star a little bit if you're doing it manually. And there isn't a convenient way in Nina to manually adjust the star position while you're looking at an image of the star. And I end up having to do it with with a different, with the, actually with the code that's used, the ASCOM code that's used to talk to the mount. So that's a frustration, and I'm sure Nick has a way he could fix that. And let's see, there's some other Nina issues that I've run across that could be better, I think. But anyway, we need to talk to Nick about that a little bit.
If you want, I can show you how to do that and how to set up ASTAP in Nina.
The controlling the line of sight.
Yeah, that's built into Nina. And regarding your ASTAP problem in the Nina settings, you have to give ASTAP more information, because ASTAP doesn't use the information you previously entered into ASTAP. It uses the information coming from Nina.
Yeah, and you have to change it in Nina. I've tried that. I've gone into the ASTAP itself, and then what's screwed up is the plate scale. And I know what the right plate scale is, and I put it into ASTAP, and I can solve in ASTAP itself. But then when I go back to Nina, it takes the plate scale from Nina. But when I go in and change the plate scale in Nina to what it should be, it doesn't get to, somehow it doesn't get to ASTAP. So that's
Is it because is there a different downsampling factor?
no, it's they're one to one. They're 1-to-1 always. I haven't messed with that. That's the binning is what you're talking about.
No, because binning, yes, but in Nina there is a in software downsampling factor. It will transfer to ASTAP if you go to plate solving.
Right. Yeah.
Which is not binning, which is
both in ASTAP. Oh, it's different than binning. You're saying the plate scale?
No, it doesn't bin on camera. It is Nina takes the full unbinned image and gives it to ASTAP with a direction to downsample.
Yeah. Well, I've always set the downsampling in both Nina and ASTAP to 1.
All right.
So I don't, that shouldn't, I mean, it seems to me that that's the right setting. But so anyway, I just need to get time to go back and play with that again and see if I can, there may be something I'm just missing, and I need another night to fool around with it. And I'm sort, you can only do it at night, so you have to waste an evening on it.
Yeah.
I think the combination of Nick, that's real familiar with coding Nina, and Scott, you're real familiar with speckle and have a telescope to try things out. I think that's a powerful combination. And Dave has supplied us with a file structure he wants to see, so we can eventually tack on automated bispectrum analysis.
Yeah.
Say, I just looked at the weather forecast, Sophia, and tonight is listed as poor conditions.
No.
And Saturday and Sunday are listed as good or normal. So if you want to move it.
Yeah. If we could do Sunday works for me. I think there's a family dinner that I've been commandeered to attend on tomorrow night, but Sunday night works for me.
If you want to move it to Sunday night, it looks like the better forecast.
Perfect. So we can do 6 p.m. on Sunday night?
Yeah.
And Scott, maybe we can do Saturday night with you if it works out with the commander-in-chief and the weather.
I'll check on that. We can put it down tentatively and see how that goes.
Dave, can you talk about file structure and automation of spectrum?
Quick question. What time for Wednesday night? Or not Wednesday night, Saturday night?
I would say we ought to start around 6 when it's getting dark.
Alrighty. I might be a little bit late, but I can try making it.
Okay.
Speaking of scheduling, are we 10 a.m. on Fridays for for the duration. So once Dave goes to Chile, is it going to move? I just am wondering whether I should reschedule my regular Friday 10:30 thing. I apologize in advance that I'll be dropping out right around then.
Well, any day works for me, like after 1:30 Eastern time. So that would be 10:30 here. But any day works, so.
Okay, I mean, if Friday 10 a.m. is going to be the time, I'll just see if I can move my 10:30 thing to a little bit later, which will also work, but I'll have to go for it today.
Well, maybe we should move to 10:30 in advance. Next week, just start at 10:30 and make it stick with that. Does that work for people?
That works for me. Also, I think Hermione is stuck in the waiting room. If you could let her in.
Thank you. Well, let's just
Dave,
plan
any
on,
thoughts on file structure and automation and reduction?
Yeah, so, we can get really complicated here, but the simple answer is, as long as you put everything that you want to get reduced under a master folder, as soon as STB finds a folder that has more than 3 FITS files, it'll assume that you want to do bispectrum reduction on it, and it'll just go ahead and do that. So you're really free to do whatever you like as long as STB can search down from a top level file and find, folder, and search down the directory tree to find any folder that has FITS files in it, basically, and it'll do the computation on those FITS files.
So it
Now-
creates the FITS, the three-dimensional, the FITS matrix, the
It'll
cube.
create a cube, and there'll be a few things that you'll have to enter, like you want it cropped or padded to 256 by 256 or 512 by 512. Whether or not it's a monochrome image, which I think we all use a mono, and so forth, just a couple of simple things, and then it will just work. So at the end of the night, you can just turn it on, give it the top level folder for that night, and it'll plow through everything. That'll create the bispectrum files that you'll need for doing the phase reconstruction. So you'll just move directly to phase reconstruction, and you'll load those things in that you're interested in and go from there. So that's the simple answer. For me, for coding it, it's really simple. For observing, though, it's much more for keeping the files organized in a way that makes it possible to go back and do the work. I found that I had to organize it in a very specific manner. And the manner that I organized it in for when I was doing GBO especially was I had underneath my account, I had the date, and then I had the target, and then under the target I had the filter, and then under the filter I had the target FITS files again for a certain exposure. And then maybe I can bring up that email that Russ, I think, is probably talking about. I'm sure I have it here.
Dave, just a quick question about what you said about the way STB works. I've always done the FITS cubes as one step and the bispectrum processing as a second step. Are you saying that if you tell it to do the bispectrum processing, it will automatically generate the FITS cubes and then process them also?
Yeah, it has to, because Nina or whatever imaging, camera control program is going to create two-dimensional FITS files, the normal image
right.
files. So I don't want to change the way that, I can change the way that STB operates, but, and use normal FITS files as they come out of the camera, or we can make cubes. And whatever, it doesn't matter either way, whatever we decide. If you'd like to have a cube at the end of it, or you don't care about the cubes, then we can discard that processing level. Nonetheless, I have to read in the images, the hundreds or thousands of images, and process the bispectrum information from there.
Sure. I just didn't know that STB would automatically generate the cubes and then process them.
Well, it'll do whatever I tell it to do, I hope.
Okay. Well,
The
okay.
whole idea. Sometimes it doesn't do what I tell it to do, and I get angry at it, and we straighten it out.
But the bottom line is it can do it all in one.
It
in
could do,
one,
it's going to
command.
have to do it all if we.
Yeah, okay.
Let me share my screen, Pat.
Yeah, it's
Oh,
free. Yep.
Thanks. So I think this is, move this out of the way. Come on. So this is what Russ is discussing. The file structure, the directory tree structure, has to be carefully managed, in my opinion, because we're going to have multiple users. So here's an example where this might be me, just one of the users. There might be other levels above this, like what observatory, whatever, the night that you're doing it, or however the program. You might break the evening into 2 or more different programs, Red Dwarfs and Discovery and all of that stuff. So there might be directory structures above this. Nonetheless, you're going to point to the top directory structure for every file that you want to analyze. And STB can just use a nice Microsoft utility that runs through everything and finds every folder in the entire directory tree. So the really interesting question is then, how do you organize it after that? So here's the way that I suggest, and this is the way I did it before, and it worked. So here's like me on this night. Here's the target that I wanted to observe, and I might want to observe that in different filter bands with different exposure times and with different, anything else you like, whatever, different times of the evening, for instance. You might want to do it early or late. Whatever you want to do, you've got to figure out how to manage that structure so that you can give the data back to the person who needs it to write the paper or whatever they're doing. So that's really the important part. Also, you've got to keep it organized so that you know that it was a red filter, and you took the, not only did you take the target in the red filter, but you also took the reference star in the red filter. So this is the way basically that I did it. Red filter, exposure time, because I had various exposure times I was interested in, the set of images, another exposure time, another set of images, and so forth. Then a new filter, and you get the idea. Then Russ inserted this because he said, well, yeah, maybe you want to do another set in red for whatever reason. That's fine. Or maybe you want to do another set in another filter band. As long as you keep the organization like this, you'll be able to sort it all back out later. So we just did the target. And now we're going to move the telescope to the reference, and we're going to do the reference for that target. And it's the same exact thing. Okay. Then we move to a new target. We do the same thing. We move to a new reference for that target. And if you label the folders like this, there's less there's less ability to be confused. There's less chance of being totally confused. When I first started this, you wouldn't believe what a mess I made. I was using targets for references for other stars because I was totally confused. You know, you get the idea. So any way that you want to organize it is going to work as long as you can recreate the scene of the crime during the morning hours when you're interested in looking at the results. Okay.
Question is that how sensitive will it be to the folder names? Does it matter?
Well, it doesn't matter to me at all. I'm just going to plow through the directory tree and find anything that looks like a FITS file and chew on it for a while. Okay.
Okay.
Yeah.
So it doesn't have to conform to anything, and there'd be no problem at the top if it were date followed by row, for example.
No, not at all.
Okay.
It's your job
Okay.
to make up what this actually, what this structure actually looks like, and you should document it very, very carefully, because I had other problems where I didn't write it down and then I forgot what I actually decided, and then 2 nights I did different things. And it's an ugly mess if you do stuff like that.
Yep. Agreed.
Would you like any more information in the image file names?
Well, that's a
Dave.
question for the observers. You gotta work this out in your own head about how it has to look, what information you want to end up with.
Dave, then given we have FITS files in this file structure, you process them and the result is a phase reconstructed bispectrum image.
No,
And where do you, no, it's not, or it
no,
is.
you get the bispectrum analysis files. So you get a bispectrum file for each collection of FITS files that are in a folder. And you
Okay,
go back in and you reconstruct it, because there's a lot of stuff happening during the reconstruction. For instance, I happen to have this up. Okay. Not only do you go in and you have to load.
But what you're filtering, what you're processing there is a single image that was created from the cubes, right?
Well, okay. So look, you get this .bsp1 file that will be done for you during the night. You get one for the target, you get one for the reference.
Oh, okay, yeah,
And you've got to bring up this
right, okay, now
window, and you've got
I
to
understand.
fill it in and whatever you want to do with filters and so forth. And then you
Yeah,
hit start and you end up, and of course, this doesn't take very long at all, right? So then you get this, and then you've got to figure out how you want to analyze it. So that's
Yeah,
all
right.
your job. My job is to produce these .bsp1 files.
yeah, so you generate the 2 files, and my question was going to be, where do you stick those? Do those go into the where you have the FITS cube, or is there a different structure for that?
That's a super great question. And I've been wondering about that for hours. And I don't have a clear picture in my mind of where they should be stuck. So if we go back to here, if we go back to here, let me get back to where I was. Where was I? I don't know. It's somewhere in here. Try it again. Let's see. I was what here, I think. Yeah. Okay. So where should the results reside after I've done the analysis? Well, they could reside really almost anywhere as long as there was sufficient information in the file name to be able to understand where it actually came from. So I could stick them at the lowest level, which would be inside of this folder. Here's where the images are, right? That's where I did the processing. I could stick them in this folder, but then you've got to go down the folder tree to find them, which frankly is actually a bit annoying. So instead of doing that, I could stick them under the filter name, but that doesn't actually make a lot of sense because that's kind of in an intermediate place. So the two places that are possibilities is inside of the original folder with the FITS files, or all the way up here under the target. And then you'd get every bispectrum analysis file that had been analyzed underneath this entire directory structure. And that'll work as long as there's sufficient information in the file name, which is my job. I have to create the file name.
The way I've done it always is to create, like you said, under the basic target or top level folder, a separate folder called bispectrum. And I just tell STB to put all the bispectrum big product files in there. And then it's very easy to go down the list and check them one at a time for each iterative analysis, the next day.
Right.
But
also,
you're right, all the names have to be unique or else you start piling things on top of each other, and that's disaster.
right. Not only do they have to, they have to be unique and fully descriptive of where they came from. And that's a problem when, when we stick if we stick this red section in here, then we have to be careful. It could have the same everything. It could be a red filter and 80 milliseconds, right? And it would have to then be, underscore number 2.
Yeah, and Rick, you often repeat it like 5 times, right?
Yeah. So I've set up, I've called them set 1 and set 2 and set 3 and put them in separate file structures. Otherwise, they all get lumped into one folder and they get processed as one FITS cube and one bispectrum output. And you've got too many in there. The whole idea of making multiple observations is to keep them separate and look at how they change to get statistics.
Right. So your automation should take care of that for you, but then they get stuck into different folders and we have to deal with that.
Yeah. The folder names, do they get, can they be carried along as bispectrum output names?
Absolutely. That's the way to, that's the only way to actually do it is to carry this whole directory tree structure all the way down in the file name.
Right.
But then there's the possibility of having multiple versions of that same name. So if we encounter that, then it'll have to be an _1 or whatever. And so I just have to figure that out. But I think I would stick everything underneath that level, because that's kind of where it belongs, right?
Right. You could add the current date and time as a number to the folder and file names. That will always be unique.
Yeah, I've done that before. I don't actually like that. I like _1, _2, and so forth, because it it helps my brain sort it out. If I have to look at a time and a date, it gets confusing.
Yeah, it's easier to read.
Yeah. But you can have whatever you like. If you want the time and the date, we'll do that. But that's the
right now,
basic.
the SciTech, we've been doing, loops of 10, for example. So just to be sure I have it clear, if we were to in that venue, we'd have target HU 376_1, and then we'd have the same thing _2 and so forth, and same for reference. And that would be the way to structure it.
Yeah, when I think about it now that you said that, what's actually going to happen is Nina has to create a new a new folder.
Mhm.
If we had this situation where we had this folder name and then this folder name, this is actually a whole new run. So this would have to actually be _1. I can't edit this, but you get the idea. This would have to be _ something or _ time and date or whatever.
Okay.
Okay. So that problem is going to sort itself out for me. I just have to go down the directory tree. And what I'll do is I'll put everything in the file name, right? I'll put that _ this _ this. You get the idea, _ this and this. And finally, that'll be the name of the, and that's guaranteed to be unique because Windows, requires a unique directory structure.
Yeah.
Okay.
So it becomes the responsibility of the observer to make sure those folder names are unique.
Well, it's the responsibility of Nina to make sure the
Oh,
folder
okay.
names are unique if you're
Okay,
doing
yeah.
automation.
Yeah.
Yeah.
Yeah, Nick is going to have to, I mean, the way the sequence function is structured in Nina, it allows you to name I believe it allows you to name the file, the directory structure, and file names. It certainly lets you adjust the file names, but I think he's going to have to specialize that for this application.
The only thing which isn't included yet is separating it into red filter 1, red filter 2. You can, everything else which is listed there is already possible with the advanced sequencer. But it's definitely a mess if you put everything into one folder, and the only difference is the file date.
Yeah. So the job of STB is going to be to run down the directory tree, create a name from the directory tree structure itself, and then stick the resulting BSP1 file underneath there, probably, or underneath there might also work. That almost doesn't matter.
Dave, is it okay if the time is in seconds?
That's totally up to the people who are using the files. For
Okay,
me,
yeah,
it
right.
could be in nanoseconds. I don't care. Right.
Yeah. So I was
Yeah.
wondering if the software will care.
My software won't. I mean, I'm just looking at a name. The name is just a sequence of alphanumerics.
How does Microsoft deal with periods inside a file name, folder name?
That's fine.
Okay, all right.
There are some characters that aren't allowed anywhere in Microsoft. You probably already know them. The ampere, the plus sign, the ampere. I think the ampersand. Anyway, whatever. You can go look at it.
Yeah.
Oh, by the way, don't put characters that don't work for Linux or Mac. That would be bad too, because then it couldn't be read. So I would stick with a standard set of characters.
And no spaces.
Well, Windows likes spaces, but I don't think
Yeah,
Linux
but-
likes spaces, right?
Right.
So,
It
yeah.
definitely doesn't.
So don't use spaces.
I do like the idea of, kind of a set 1, set 2 set 3 so far that's human friendly.
Yeah, so the way I do that is I just run a counter. Every time I encounter a folder name, I run a counter. But in this case, I don't even have to do that. Nina's got to do that because it's got to make unique folders. So this really isn't even my job. My job is simply to run through the directory tree, create names for the BSP1 files and do the processing.
Great. I'll write Nick over Slack that we have to separate that into _1, _2. But as said, everything else is already in the sequencer as is. So this shouldn't be a problem.
Okay, that takes care of that. While I have your attention, let's go back to a question that we had on Wednesday, which is about the angle. So Scott observed that even though I have 0 for the camera angle, I've got 2 different numbers here for the plate and for on sky. The reason for that is that I set it up a long time ago, I think for Kit Peak, and Kit Peak had I don't remember if it's an even or an odd number of reflections, probably odd. And so this is simply the complement of this through 180 degrees. So the sum of this and this is 360. Okay, or
I got it.
it's
Yeah.
image through 180. And I did that for a particular telescope. And then I tried like hell to add check boxes and stuff, but that didn't work because nobody knew what to do with any of it. So I kind of dropped it out and left it, but I could put it back, but you know, anyway, it is what it is. Maybe we should leave that alone.
Yeah. Got
Okay,
it.
so that answers that question. Camera angles are super confusing. That's why my recommendation is to set your camera a few degrees off of north, do a known double, get it all figured out and write it down. And then you just repeat that algorithm every time. And if you don't do that, I've been horribly confused and even have given people wrong information by not understanding what I was doing with their telescope. Okay, so that takes care of that. We talked about HR diagrams and finding superluminous stars or stars that aren't on the main sequence, which is kind of interesting. So this is an HR diagram. These are 3 different ones. This is out to 200 parsecs. This is out to 100 parsecs, and this is out to 50 parsecs. So you can see what's happening. And it shows you that one thing it shows you is that we're not in any unique place in the galaxy because I think they're essentially identical except for the number of population, you know, the amount of stars that are in it. Of course, it should shift to the red end. And you can see that this is out to 200 parsecs. There's a lot of blue stars. And then when you get over here, the blue stars taper out in a relative density sense, and you get more red stars when you're closer. That's because the universe is dominated by red stars. And it totally makes sense. So I've created a catalog that goes out to 200 parsecs. And that catalog contains every star in Gaia DR2 that has a parallax and 2-band photometry. And that will allow me to write a tool of some kind. I'm still wondering what that tool actually looks like because it has some interesting complications. I mean, we might want to observe some of these weird, I don't know what, I honestly do not know what these stars are.
So
they exist.
I actually came up with an idea for that.
good. What's your
Uh,
idea?
So I was watching a video on how scientists would go about detecting megastructures like Dyson spheres. And they talked about the fact that when you have a large object orbiting around a star, it can cause the star's luminosity to dip down below what its temperature is expected to be. So I was thinking that those stars we might want to look at for being in or around large nebulous structures, or possibly even stars that might have protoplanetary disks around them.
Oh, wow. Yeah, that's really a great observation. So whatever these things are, they're interesting. Maybe some of them are actually Dyson sphere.
Yeah.
No, an actual Dyson sphere would have more in the infrared, and so it would actually appear cooler than what its
Right.
luminosity would indicate.
Or a leak. This could be a leaky Dyson sphere. We're only getting 1% of the leaky Dyson sphere. Okay, so
Dyson
whatever
sphere
it is,
1.0.
so I'm still thinking about how to write the tool that allows you to select a particular star. I'd love to actually be able to like zoom in and just pick like a region,
Mhm.
draw a region around that, hit a button, and it gives you a list of all of the objects in that region. That would be fun, huh?
Yeah, another thing you could do it a little bit like GDS, where you can tailor a program for a particular telescope and time of year and location and so forth. So you can put in the R index and magnitude of the limits of bright and dim, and then maybe something like you're talking about where you can select maybe a distance from the main sequence. But yeah, if you had a really, if a tool allows the user to adapt, kind of search through your catalog in a useful way to make up a target list.
Yeah, well, that's the puzzle that I'm working on in my head. I would love to be able to go in and just select like that group, that group of stars there, say, and then have the other selection criteria come up like RA, deck, brightness, and so forth, color. Well, this defines the color index. And it defines the brightness of the star too, really, because so the only other choices you'd then have would be RA and deck, I think, after that.
Well, maybe you could produce some sub catalogs. So you have your overall catalog, and then maybe you could go in yourself and select regions, rectangular regions, and have those as subcatalogs, and then kind of use a GDS type tool to make up target lists from your subcatalogs.
All certainly possibilities, right?
Hey, Dave, could you just define a rectangle in brightness, color, so a range of brightnesses and colors, and then so that would define a rectangular region, and then let them define the distance from your polynomial fit within that rectangle. That would give a reasonable subset, I would think, of the ones that are possibilities.
Yeah.
Does that make sense?
Well, they all make sense. So
Yeah.
you guys are going to be the no,
Just
they
have
all
to
do.
choose one.
Yeah, you guys are going to be the users of this thing, I presume. So, what would you like to have? And we'll just do it that way. Figure out, maybe come next week with ideas about how you would like to select these things. There's a lot of stuff going on here. How do you want to select? If you wanted to go look for white dwarfs, it would be nice to be able to draw a region around that. I also made a catalog that should still be in existence somewhere. of all of the white dwarfs on this branch. And I made a catalog of all of the red dwarfs that are on this branch. Well, this branch. And those catalogs already exist as CSV files. So you could sort to your heart's content on those too. But it is an interesting, little problem in interfacing. I think that's all I had today.
Could I ask Leon? I think you mentioned earlier that you knew a way to adjust the line of sight a little bit while watching an image in Nina. And if you could just write down an explanation of that and email it to me, that'd be great.
Yeah, sure, will do.
Dave, you said you already have catalogs for white dwarfs and red dwarfs. And those can be searched like by parameters that are in Gaia.
Those are CSV files. So
Oh,
you
okay,
have
so they-
to, you can search in Excel.
Yeah, okay, they sorted in Excel. Okay.
Yeah.
That seems like everything that's needed. It's already there.
Yeah, so you got the red dwarf branch and the white dwarf branch.
Yeah,
And I sent that to you already, so it's somewhere in your email.
I don't know. I guess I missed it or I was unconscious that day.
Well, maybe Russ has it, or I can go try to find that email, but not right now. So,
Oh, what email is it? I'm sorry, I was fixing my coffee.
yeah, so it's the, I created two CSV files, Russ, that I remember. One was for the red dwarf superluminous branch, and one was for the white dwarf superluminous branch.
Yeah, I do remember that.
Was that a few months ago or more
Could be a
recently?
year ago.
Year
Oh.
ago, okay.
Yeah,
I'll go back and
look.
look.
I'll look too.
And that was an attachment or is that a link to a
I don't
cloud?
remember.
Yeah, okay. It seems like it'll be a big file.
Yeah, so these
Yeah.
were kind of sub catalogs.
Okay.
Yeah, so you
You
can
know, I
bring your
remember looking
ideas.
at it and I played around with it. I put it on the spreadsheet and started making up target lists from it.
Yeah.
Okay.
Dave, one more thing. What you mentioned 2 minutes ago, you mean in the UI sense, like literally drawing a polygon around the stars you want, or searching a file, or just searching by parameters you enter?
No, literally drawing a region of interest. Yeah, around the
Yeah.
stars you're interested in. Yeah,
Yeah, that'd be great.
an
that'd be
arbitrary
cool.
shape.
Do you have, you need to have a test folder to, or have you already got that? Do we need to develop a test folder for, example, going through the file structure, the directory that you've defined?
I don't have an example, no.
Okay, so if we got one, it might help.
I mean, I think that you should spend some considerable amount of time and thought on this and discussion about exactly what that thing looks like, because the person that programs Nina is going to have to know precisely what that looks like, and it has to be well documented. And also, believe me, if you get it wrong, it's just pure misery.
Yeah.
Yeah.
Okay.
Dave, if you remember for Photo Center in Chile, for the CDK24, the file structure there basically already does what you described.
Mhm.
The only thing, as said, is what's missing is that _2. But if you want an example for that, you can just copy that.
Yeah, well, I'm not going to get involved in this any further, except to tell you what, I did and what seemed to work for me okay. And just to warn you that it was, I did it wrong, and it's just not very pleasant to try to go back and like horrible, right? Yeah. So, and I know that, Russ has been talking about, and it's a good idea. You have even different programs. So you're going to have levels that may be even above the one that I showed. And I think you should work that out too, because I think Nina can take whatever directory structure at the top level you want. You can have it be what you want. But if you don't do that now, you probably get one shot at this, is what I'm trying to say.
And I agree. If you get it wrong, you can spend hours trying to figure out what happened and then still not be sure and end up just dumping the whole night's data because you
Yeah.
can't make sense of it.
Right.
It's a real disaster.
Yeah, it's really a
Yeah, I
stomach
agree.
wrencher when you get it wrong. Yeah.
I
I've
also
done
really
that
like
often
the idea
enough
of
to
separating into users.
really
I don't
want to
know.
be careful. Dave, if there's a little time left, well, there isn't much, but could you show us that HR diagram again? You zoomed in on the tail end of the red dwarf branch, I think.
Yeah, let me go get it.
I was just wondering if you could brighten that a little bit and see more clearly the superluminous branch and whatever scatter of stars there are in between the two
Right.
branches.
Which parsec one, Rick?
Well, I don't
The
care.
nearby one?
Yeah, the nearby one's fine.
The nearest by one, huh? Okay. Yeah, this is out to 50 parsecs. I guess I got to share my screen, huh? Yeah. Okay.
Yeah, can you brighten that to show it? Okay, so there's the bright branch, and then there on the left of it, there's the dim branch. Is that the white dwarfs?
Yeah.
Oh, okay.
Well, I've never really fully understood. This must be a sampling bias problem of some sort.
Yeah, maybe so.
I think so.
But I think there was a view before that showed a definite distinct concentration off to the little bit to the right. And I was assuming,
this thing
no, off to the right of it.
over here.
Yeah, there was another little tail. Now maybe it was a farther out.
Well, let me
on the
bring up
sample.
the farther out one, huh? Open image. Here's 200 parsecs.
Yeah, that's it. Can you zoom in on this region? Yeah,
Over
see,
here?
there's a definite concentration off to the right, which I assume is binaries.
Here?
Down at the bottom. There we go.
Here.
Yeah,
These are,
yeah,
this is the superluminous branch.
right.
And
And it sort of
extends up-
has, it sort of has a definite limit to it, but there's a lot of stars in between, which implies that the secondary is fainter than the primary, whereas the limit is kind of where they're equal brightness.
So maybe this will help us a little bit, maybe not. I don't know. That helps a little bit.
Yeah, and then there's a bunch out here that are even brighter than twice the brightness. That I've always wondered what the heck are those guys?
These guys out here.
Yeah,
Yeah, me too. I've wondered a lot about this HR.
yeah.
Mhm.
I mean, a lot. There's
And-
odd fellows over here too. So,
Yeah. There's a lot of physics going on there.
yep, there's plenty of interesting physics, as Nate pointed out. This could be due to whatever, going through clouds, reddening, dust. There's a lot of stuff going on here. That
Even the white dwarf branch there has a split in the middle. And I think the people that were looking at this the first time in that big paper from the Gaia Consortium, they talked about that, but they weren't sure what the heck is that.
Yeah.
What do you
I
think?
mean, it's
the,
fast. It's
rectangular
really fascinating.
matrix is there? What's, you know, that you see the pattern of sort of a rectangular or square even matrix in that image. What would that be from? I mean, it's something in the data, of course, but
Right. I don't think that this is an artifact. I think this is real, and I don't know what it is, but there is a weird artifact perhaps here that has to do with sampling bias. I really
Yeah.
don't know. I mean, you could spend your life on this one.
Pat, that sort of checkerboard pattern overall might just be a sort of round off error somewhere in the
yeah,
either in Gaia or data originally or
Yeah.
or somewhere along the line in plotting it.
yeah. It looks like it. Is it, you said you can't zoom in
Well,
on.
remember, this is a
dot.
histogram, so this has been binned.
Yeah, it's a binning
So-
artifact.
So this isn't actually an artifact, it's just been binned. It's an
Right.
occurrence density, right?
Right.
So,
Did you said
This
you
isn't
can't
a-
zoom in on a particular dot and tell which star that is, right? If you,
Yeah, another interesting feature on that diagram seems to me is that there's an absolutely vertical line at some, whatever the, I don't know what the color ratio is, but it's just straight up and down. And what on earth could cause that sort of a structure in the diagram? It just totally seems to be totally vertical.
mhm.
So it's some ratio, the stars start to appear, and below that ratio, there's none.
well, if anybody has any ideas, please send me an email. I'd love to know too.
Well, the one thing we can contribute is we can have a little program where we sample these,
Yep.
looking for binarity that we're capable of seeing that other people haven't had the time, or, you know, because it's kind of one star at a time. We got the telescopes in time, so we could contribute.
Yeah.
For sure.
And if we can't find it with speckle, it might show elongation, and we use some of our techniques that we've developed for, nailing down the elongation. So I don't know. This is a really curious bit of business. The more you look at this diagram, the more you wonder about it.
I unfortunately have to head out, but it looks really
Oh,
cool.
sorry.
New
Okay, so-
observation project for some students, perhaps.
Yeah.
Yeah, so maybe see you
Bye-bye.
Saturday night or Sunday night or both.
Yep. See you
Great.
Saturday and Sunday. Bye.
And I could discuss this for a long time. Let's not do that. You can go down this rabbit hole a long way.
Yeah.
Okay. Well, then I guess that was a kind of a fun meeting, huh?
It
Yeah,
was
it
was
very
fun.
productive.
This,
Okay, well,
and we'll see you all
Anything
next week
Yeah,
at this
yeah.
time or at 10:30.
10:30, we'll move to 10:30 so it's consistent.
Okay,
Yeah.
we'll start 10:30 again.
Sounds good.
Great.
All right.
Cool.
Great
We'll
to see
also
you.
have automation next week too. Remember that 10 o'clock on Thursday is the automation meeting.
Okay,
All right.
bye-bye.
Bye-bye,
All right,
everybody.
see you.